The previous lecture, we discussed separable differential equations. Let me, why it is not working? Yes. So in the previous lecture, we discussed separable differential equations. Separable ODEs, in fact. Today, we are going to discuss equations or linear ODEs. So I told you previously what is a linear equation. Linear equation is basically an equation of the form, for example, uh, first order linear equation is basically a1 of x dy by dx plus a naught of x y is equal to some function, maybe f of x. We can write this linear equation into the standard form as so. In order to solve any linear equation, first we have to write that equation into the standard form. What is the standard form of this equation? We divide this equation on both sides with this a1 of x. We divide on both sides with a1 of x, and we have to impose an additional condition, which I shall write here, plus a naught of x divided by a1 of x into y is equal to f of x divided by a1 of x. So here the additional condition is that is a1 of x should not be 0 for any real number x belongs to R. A1 of x should not be 0. Now the coefficient of this dy by dx is 1. So this is basically the standard form. Whenever we are given an equation of this form, we have to transform it into this form first before solving this equation. Now this equation further can be written in this form. We say that we assume that this a naught of x divided by a1 of x is some function p of x. Y is equal to, and this function is some other function, maybe g of x. Okay, now this is basically where p of x is a naught of x divided by a1 of x, and g of x is f of x divided by again a1 of x. Okay, now this form is the standard form of linear equation. We have to solve this equation. Whenever we are given this kind of differential equation, first we have to convert it into this form, which is the standard form of the linear equation. And how do we solve it? How to solve it? Now, in order to solve differential equations, if it is a first order differential equation, you know that we have to integrate that equation one time. So whenever we have a differential equation of this form, dy by dx plus p of x, y is equal to some g of x, we cannot integrate it straightforward. Okay, we have to do something in order to integrate both sides. So here we notice that here we have dy by dx and here we have y along with some function p of x. if I multiply with a factor e power p of x dx on both sides of this equation, if I multiply this equation with this factor, and this factor is called integrating factor, okay? It is integrating factor. Now, we multiply this equation with this expression on both sides, and we obtain e raised power integral p of x dx into dy by dx plus you can say p of x e raised power integral p of x dx into y is equal to g of x times e raised power integral p of x dx. Okay. Now, why did we multiply this equation with this factor? Why? Now, in this equation, you notice that the left-hand side, this one, the left-hand side of the equation, this one, has become the product rule of the two functions. Let me go to the second board, maybe. This one. You can see that the left-hand side has become the dy by dx. You can see me, I hope. This one. Dy by dx of y into e raised power integral p of x dx. This one is equal to g of x e raised power integral p of x dx. Now, you can see that whenever we open this derivative, we use the product rule. The first function is this one, and the second function is this one. We can take the derivative here. Here, यहाँ पे क्या आ जाएगा? पहले function का derivative dy by dx. This function as it is. ठीक है? We get the first term of that equation. ठीक है? चलिए ले लेते हैं. पहले इसका derivative लें तो क्या आ जाएगा? dy by dx. This function as it is, e raised power integral p of x dx plus फिर y as it, ठीक है, और इसका डेरिवेटिव e raised power integral p of x. इसका डेरिवेटिव क्या होगा? e raised power integral p of x dx और फिर इस इंटीग्रल का डेरिवेटिव क्या होगा? p of x, ठीक है, और साथ में y as it is. Now, if you notice that we again get the left-hand side, which we have there in this equation. So we have e raised power p of x dx dy by dx plus p of x e raised power integral p of x dx into y. So this left-hand side will always be written as a product rule of the two functions where y into the integrating factor. Okay? You can see here, you can apply the product rule here. Now, this equation, from this equation, we can integrating now, integrating both sides with respect to x. What do we get? जब हम इंटीग्रेट करेंगे तो यहाँ पे डेरिवेटिव है, डेरिवेटिव और इंटीग्रल कैंसिल हो जाएंगे. What do we get? We get only this this expression which is inside this derivative. So we obtain y into e raised power integral p of x dx is equal to the integral of this thing, integral of g of x into e raised power integral of px dx whole dx plus some constant c. Now you can see that the derivative has been removed from the differential equation. In order to solve, I told you, in order to solve first order differential equation, what we have to do, we have to remove that first order derivative from the equation. There must be some reasoning behind uh, removing the derivative. Means we have to take integral in order to remove that derivative. Sorry. So we cannot remove derivatives by taking integrals straightforward on the both sides of the given equation. So we have to make here on the left hand side the product rule first, and then we can take the integral both sides, and this derivative will be removed, and we get this expression. Now solving this expression, we can get the answer because there is no derivative in this expression. So solving this expression, we can get our answer. Let me add the people. They are waiting. Okay. Let's do some examples, couple of examples for to understand this method. For example, maybe example 1. Divide by dx plus minus 3y is equal to 6. Okay. Example 2, maybe a little bit difficult. Maybe dx divided by dx minus 4y is equal to x raised by 6 into e raised by x. Now, these are two examples of linear equations. I'm going to solve the second one. The first one obviously is comparatively easy than the example 2. Now, you can see we have to solve this equation. And you can see that we cannot separate the variables here. So this equation is not separable. We cannot solve this equation by using separable, by separating the variables technique. Okay. We cannot solve this equation using that method. So we have to introduce some new method. Well, this is the second method we are going to discuss in order to solve these kind of differential equations. So what we have to do, first we have to convert this equation into standard form. Standard form में सबसे पहले आप इसको convert करेंगे. How do we convert it? We divide the coefficient of dy by dx, which is x, on both sides of this equation. So by dividing by x, what do we get here? 4 by x y is equal to x raised power 6 है यहाँ पे, तो 5 हो जाएगा e raised power x. But remember here that x cannot be 0 now because x is here in the denominator. Now this is basically the standard form of the linear differential equation where you can see that what is p of x? It is minus 4 by x. And what is your this thing which is g of x? It is x power 5 or into e raised power x. But you don't need it. You only need this p of x in order to find the integrating factor. Now, what would be the integrating factor here? It will be always e raised power p of x dx. Okay. Now, what is e raised power p of x? P of x is negative 4 by x dx. और इसका इंटीग्रल क्या होगा? E raised power minus 4 natural log of x. ठीक है. this one. यहाँ पे देखिए, we can use the property of log. यहाँ पे क्या आ जाएगा, e raised power में से log x पावर -4, क्योंकि log के बाहर जो होता है, log की प्रॉपर्टी है ये, पावर में जाएगा. अब यहाँ पे e और नेचुरल log आपस में कैंसिल हो जाते हैं. And what do we get? We get only x raised power -4, which is 1 over x power 4. So our integrating factor is 1 over x power 4. The integrating factor we obtain, it is 1 over x power 4. Now multiplying this equation by integrating factor on both sides. अगर आप इसको multiply कर देंगे यहाँ पे, तो what do we get? 1 over x power 4 dy by dx minus 4 over x power 5 y is equal to x power 4 से डिवाइड करेंगे तो आपके पास x e raised power x आ जाएगी. ठीक है जी. This is what we have obtained here. Now, can you see that this left-hand side has become the product rule of y and 1 over 4, x power 4, integrating factor. This thing now has become, I'm going to write it here. Now, this thing has become the derivative d by dx of y into 1 over x power 4, where y is the dependent variable and 1 over x power 4 is the integrating factor. You can see that if we open this derivative, this product rule, we must obtain this left-hand side. If we take that derivative, do we obtain this? Yes. Now, this is equal to x into e raised power x. Now integrating both sides, with respect to x. यहाँ पे इंटेग्रल लेंगे, ठीक है, यहाँ पे इंटेग्रल लेंगे और यहाँ पे इंटेग्रल, ठीक है. This thing into dx. यहाँ पे डेरिवेटिव और इंटेग्रल कैंसिल हो जाएंगे. What we have obtained y into e raised power 4 is equal to, यहाँ पे x into e raised power x है, we have to use integration by parts here. So x as it e raised power x का इंटेग्रल e raised power x minus x का डेरिवेटिव 1 और e raised power x का डेरिवेटिव e raised power x dx and plus c, which is the constant of integration. Now, further simplifying it, y into 1 over x power 4 is equal to x e raised power x minus e raised power x plus c. Now, multiplying both sides now by x power 4, y of x is what? Sorry. It is x raised power 5 e raised power x minus x raised power 4 e raised power x plus c times x power 4. So this is your solution, which is the required solution, which is the solution of given ODE. I hope you get it. If you have any question, you can ask. If you have any question, you guys, you can ask me. No question?
Sir,
जी बोले.
can you repeat from the part where you integrated both sides? उसके अच्छा
कहाँ पे? ये जो इक्वेशन अभी हमने सॉल्व किया है उसको.
जी जी, वो आपने जब दोनों साइडों पे इंटीग्रेट किया था उसके बाद से रिपीट कर सकते हैं?
हाँ, कर लेते हैं. यहाँ पे है ना. ठीक है. In fact, whenever we multiply that standard equation on both sides with the integrating factor, on the left hand side, we must obtain the product rule of y and the integrating factor. ठीक है. यहाँ पे हमारे पास प्रोडक्ट रूल आ गया था, डेरिवेटिव है, हमने इंटेग्रल ले लिया यहाँ पे, और राइट हैंड साइड पे भी इंटेग्रल ले लिया. ठीक है. अब जो लेफ्ट हैंड साइड पे इंटेग्रल और डेरिवेटिव है वो कैंसिल हो जाएंगे. व्हाट डू वी गेट? वी ऑब्टेन ओनली this expression which is inside that bracket, inside that derivative. So in derivative integral cancel हो गए, we get the same thing here. राइट हैंड साइड पे आपके पास x into e raised power x है. यहाँ पे तो इंटीग्रेशन बाय पार्ट्स लगेगी. ठीक है. Here because we have a product of two functions, so I applied here integration by parts plus a constant of integration. ठीक है. बाकी तो अब इसको सिंप्लीफाई करना है. सिंप्लीफाई करने के लिए यू नीड टू हैव गुड टेक्निक्स ऑफ इंटीग्रेशन. ठीक है. तो आपकी अगर टेक्निक्स ऑफ इंटीग्रेशन अच्छी हैं तो यू हैव टू इंटीग्रेट these functions. After integrating and simplifying, we get the answer, which is this one. It's a one parameter family of solution. इसमें एक constant of integration involved है. तो constant of integration को हम कैसे find करते हैं? हमने ये previous lecture में discuss किया था. We need an additional condition. Normally that condition is initial condition, which is defined on the initial value of the solution of the function y of x. So we can find that constant c. Otherwise, this is your general solution, or you can say it one parameter family of solutions जो कि हमने last time discuss किया था काफी डिटेल में. I hope you get it. If you have any further questions, you can ask me. Let's do another example, then you will understand it. I think. Let's have another example. Example 3 maybe. The example is this one. Find the general solution or solve the following ODE. Find the general solution of the following ODE. X square minus 9 dy by dx plus xy equal to 0. ठीक है. Now here, the given differential equation is linear, yes. No, but it is not in the standard form. First, we have to write the standard form of this differential equation. This linear equation. Standard form में क्या होगा, आप इससे divide कर देंगे. But before dividing it, what we have to write here that x cannot be 3 or minus 3. Here you can say that x is not equal to plus minus 3. Okay? Otherwise, you can divide with this factor because it will appear here in the denominator. And if x is plus 3 or minus 3, there will be nothing and you would have an undefined expression. So dy by dx plus x over x square minus 9 y equal to 0. Right hand side पे 0 है already. So we get 0 here. With x is not equal to -3 or 3. Now, this differential equation is defined basically on what? For all x, but x cannot be plus minus 3. For all x आप ना लिखें, यहाँ पे लिख दें आप for all x belonging to r minus 3 and minus 3, या आप कह सकते हैं for all x belongs to minus infinity to minus 3 union minus 3 to 3 union 3 to infinity. Okay. So this differential equation is defined for all x on this interval, okay, where x cannot be plus 3 or minus 3. In this example, we shall also see that differential equation might be defined on some different interval and its solution might be defined on some different interval. Okay. These are two different things. Now, this differential equation is valid for this interval. This is the domain of that differential equation. Okay. Now, let's try to solve this differential equation. Then we shall see that what would be an appropriate interval of solution, or the interval where the solution is defined. Now, what is p of x here? It is x over x square minus 9. Now, what we have to compute the integrating factor. Integrating factor would be e raised power integral x over x square minus 9 dx, which is what? इसको इंटीग्रेट करने के लिए x square minus 9 है, x square का डेरिवेटिव ऊपर है 2x, so we can write it 1 by 2 integral 2x over x square minus 9. तो आपके पास इसका डेरिवेटिव ऊपर है, तो we can write it e raised power 1 by 2 natural log of you can say x square minus 9, this one. ठीक है. अब यहाँ पे देखें, ये जो आपके पास 1 by 2 है, नेचुरल लॉ की प्रॉपर्टी को यूज करते हुए इसको हम पावर में लेके जा सकते हैं. ठीक है. इसको पावर में अगर लेके जाएं तो इंटीग्रेटिंग फैक्टर आपके पास क्या आएगा? e raised power नेचुरल लॉग ऑफ x square minus 9 पावर 1 by 2. अब e और log कैंसिल हो गए, आपके पास you get square root of x square minus 9. This is your integrating factor. ठीक है जी. Now, integrating factor से आप multiply करेंगे this equation. You need to multiply this equation with the integrating factor. What we obtain here, we obtain x square minus 9 dy by dx प्लस जो स्क्वायर रूट है यहाँ पे, तो आपके पास क्या आ जाएगा? x डिवाइडेड बाय स्क्वायर रूट ऑफ x square minus 9 टाइम्स y इज इक्वल टू 0. ठीक है. अब आप देखें लेफ्ट हैंड साइड आपके पास क्या बन जाएगी? d by dx of y into 1 over, sorry, not 1 over, into square root of the integrating factor x square minus 9 equal to 0. Now, integrating both sides, what do we get? Integral derivative cancel हो जाएगा. What we have obtained, this is x square minus 9 equal to 0 का इंटीग्रल क्या आ जाएगा? Constant c. ठीक है. Now from here we can write that y of x is what? It is c divided by square root of x square minus 9. Now this is the solution of the given differential equation. We can see that the solution is defined only on minus infinity to minus 3 union 3 to infinity. Okay. This solution is not defined on minus 3 and 3. ठीक है, इस इंटरवल पे ये डिफाइन नहीं है. क्यों डिफाइन नहीं है? क्योंकि माइनस 3 और 3 के दरमियान अगर कोई नंबर यहाँ पे पुट करेंगे तो स्क्वायर रूट में अंदर इसके इनसाइड पे नेगेटिव आएगा, and the square root of negative number is not defined here. Okay? That goes to the complex numbers. We don't consider them here. Now you can see that the differential equation. You can see that the differential equation is defined on this interval. Okay, minus infinity to minus 3 union minus 3 to 3 and 3 to infinity, because the only values on which this differential equation is not defined are minus 3 and 3. So you can say that this differential equation is defined for all real numbers except minus 3 and 3, or you can say that on this interval, this equation is defined. But the solution of that differential equation, we have obtained the solution. It comes here. It is c over this thing, square root of x square minus 9. So this denominator is not defined on this interval minus 3 to 3. So we have to exclude this interval from the domain of that differential equation. So the solution is defined only on this interval, not on this. So what we have learned here, first thing, how to solve linear differential equation. And the second thing is the differential equation may be defined on some different interval, whereas its solution might be defined on some different interval. Okay? So you have to keep this thing in your mind. Interval of the definition of the differential equation may be different from the interval of the solution, where the solution is defined. I hope you get this point also, and you also get how to solve the linear equations. If you have any question, you can ask me. I give you 1 minute to look at this example. If you have any question, then you can ask me. Now, another example of the linear differential equation is if we have discontinuous coefficients. Another example, which is with the discontinuous coefficient. Coefficients or the right hand side. We need to solve the following initial value problem. Initial value problem, I hope you know what is initial value problem. We discussed it in the previous lecture. 1 plus x square dy by dx plus 2xy is equal to f of x, where f of x is what? It is x minus x when 0 is less than or equal to x less than 1, and the other one is when x is greater than or equal to 1. So in this example, the right hand side is a piecewise function. How do we solve this kind of differential equation? Because here The right hand side is discontinuous function. Maybe you can say that piecewise continuous function. It is not discontinuous, but it is piecewise continuous. अगर हम इसका ग्राफ प्लॉट करें तो क्या आएगा? 0 से 1 तक आपके पास x है, मींस यहां से 0 से लेकर 1 तक आपके पास x है. तो इसका ग्राफ क्या होगा? 0 से लेकर 1 तक ये x है, लेकिन 1 पे ये ओपन होगा क्योंकि लेस देन 1 है. ठीक है. और जब 1 से बड़ा है तो आपके पास नेगेटिव x है. ठीक है. तो नेगेटिव x क्या आएगा? जब x की वैल्यू 1 होगी तो इसकी -1 होगी. तो यहाँ पे -1, तो ये यहां से स्टार्ट होगा. ठीक है. और ये यहां से नीचे जाएगा. ठीक है. एंड सो ऑन. दिस इज बेसिकली discontinuous function. This right hand side f of x is discontinuous function. ठीक है. इसका ग्राफ यही होगा ना. 1 0 से 1 ले 0 से 1 तक x है, और फिर 1 से आगे जब जाएगा तो ये -1 है, तो ये यहाँ से नीचे जाएगा. डेफिनेटली यही ग्राफ होगा. ठीक. और ये यहाँ से आपके पास it goes until infinity. So this will be the graph of this function.
सर
जी जी.
सर अच्छा सही है, सॉरी समझ गया.
ठीक है. चले. Now we have to solve this differential equation where the right hand side is this continuous function. What we do here in order to solve this differential equation, we solve this differential equation for these two intervals separately. ठीक है. तो आपके पास अब डिफरेंशियल इक्वेशन बेसिकली दो डिफरेंट इंटरवल्स पे सॉल्व होगी. पहले 0 से 1 पे सॉल्व होगी और फिर x greater than equal to 1 पे सॉल्व होगी. वो so we have two set of problems. First one is 1 plus x square dy by dx plus 2xy equal to x. ठीक है. ये यहाँ पे x डिफाइन है greater than equal to 0 और less than 1. ठीक है. ये आपका फर्स्ट प्रॉब्लम हो जाएगा. सेकंड प्रॉब्लम आपका सेम, बट राइट हैंड साइड शुड बी डिफरेंट. डिवाइड बाय dx plus 2xy equal to minus x whenever x is greater than or equal to 1. यहाँ पे तो अब आपने इन दोनों प्रॉब्लम्स को सेपरेटली सॉल्व करना है. ठीक है. सेपरेटली सॉल्व करेंगे, आपके पास दो सॉल्यूशंस आएंगे. एक सॉल्यूशन होगा 0 से 1 इंटरवल पे, एक सॉल्यूशन होगा x greater than equal to 1 पे. ठीक है. अब दोनों सॉल्यूशंस में आपके पास दो कांस्टेंट ऑफ इंटीग्रेशन आएंगे. एक इसमें कांस्टेंट ऑफ इंटीग्रेशन आएगा, उसको हम c1 कह देते हैं. एक while solving this we get some other constant of integration, we call it c2. ठीक है. I'm going to write directly the solutions, and I hope you can solve these two separate problems. ठीक है. So I get two solutions. Let me write those two solutions. On this board, maybe. Yes, yeah. The solution is what? Y of x, it is 1 over 1 plus x square multiplied by x square by 2 plus c1 when x is between 0 and 1 less than 1. And the other solution is again 1 over 1 plus x square and minus x square by 2 plus c2 whenever x is greater than or equal to 1. So this is basically, these are two solutions on the different intervals which we have obtained by solving those two problems. This one is the solution of the first problem with a constant of integration C1, and this one is the solution of the second problem with a constant of integration C2. Now, there are two constants here, and the solution is basically, you can say that we have two different solutions for two different domains, two different intervals. Now, the solution of any differential equation must be continuous and differentiable. Why? We'll discuss it in the next lecture, but for the time being, you remember that the solution of this differential equation, of any differential equation, in fact, it should be continuous and its first derivative should be continuous as well. Why? Because in first order differential equation, we have one derivative, okay, and the solution of that differential equation should be some function who is differentiable up to first order. अगर वो differentiable है first order तक, तो definitely वो उसको हम जब differential equation में insert करेंगे तो उसको satisfy करेगा, तभी satisfy करेगा जब उसका first derivative exist करेगा. So for the first order differential equations, the solution should be differentiable function up to order 1. अगर differentiable function है तो that function must be continuous as well. Okay? तो यहाँ पे हम एक तो initial condition use करेंगे in order to find one constant, maybe C1 or C2, it depends on the nature of initial condition. And in order to find the other constant, we use the condition of continuity of some function. Okay? Condition of continuity of a function, ये क्या होती है? We'll discuss it. But first, we need to use the initial condition in order to find one constant. Initial condition क्या given है यहाँ पे? Initial condition is मैंने नहीं लिखी यहाँ पे. Initial condition must be given y of 0 is equal to 0, because this is initial value problem. So ये differential equation है with IC or subject to initial condition y is equal to 0 is equal y of 0 is equal to 0. ठीक है, वो मैंने second board पे लिख दी है वहां पे. ठीक है. Now the condition is this one. With the initial condition y of 0 is equal to 0. अब हम ये initial condition use करेंगे in order to find one constant, maybe C1 or C2. It is y at 0 is equal to 0. Okay. What does it mean? That whenever x is equal to 0, y is 0. Now, looking at the solution and the intervals, whenever x is equal to 0, what do we have? We have this solution. So by using this initial condition, we can find C1, because when x is 0, when x is equal to 0, we have to use this solution. So हमारे पास ये पहले वाला solution जो है, ये क्या आएगा? For example, इसको हम y1 कह देते हैं. ठीक है? So y1 of x is equal to 1 over 1 plus x square times x square by 2 plus c1. अब इसको हमने y1 कहा, y1 में ये initial condition use करेंगे, यहाँ पे भी 0, 1 over 1 plus 0 times 0 plus c1. तो यहाँ पे c1 की वैल्यू क्या आ गई? यहाँ से c1 की वैल्यू क्या आ गई? 0 आ गई. ठीक है. C1 की वैल्यू 0 आ गई, तो आपके पास जो सोल्यूशन है वो अब हम क्या लिख सकते हैं? सोल्यूशन आ जाएगा 1 over 1 plus x square into x square by 2. मीन्स आप यहाँ पे x square divided by 2 यहाँ पे लिख दें. तो ये आपके पास 0 less or equal to x less than 1, और अब आपके पास 1 over 1 plus x square times minus x square by 2 plus c2 for x is greater than or equal to 1. अब आपके पास सोल्यूशन ये आ गया. नाउ यू हैव टू फाइंड द वैल्यू ऑफ C2. ठीक है, C2 की वैल्यू आपने यहां पे फाइंड करनी है. C2 की वैल्यू फाइंड करने के लिए वी नीड टू यूज द कॉन्टिन्यूटी कंडीशन. यहां पे C1 की वैल्यू 0. In order to find C2, we use the condition of continuity. Why? Because in first order differential equation, the solution should be differentiable up to order 1. ठीक है, तभी तो उसका solution हो सकता है, otherwise नहीं हो सकता. अगर आपके पास second order differential equation है तो उसका solution 2 times differentiable होना चाहिए, तब हम उसको prove कर सकते हैं कि वो solution है या नहीं. यहाँ पे अगर फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन का सॉल्यूशन अगर डिफरेंशिएबल है तो इट मस्ट बी कॉन्टिन्यूअस. इन ऑर्डर टू फाइंड दिस कांस्टेंट C2 वी यूज द कंडीशन ऑफ कॉन्टिन्यूटी ऑफ फंक्शंस. वो क्या होती है? लिमिट x अप्रोचेस टू 1. why 1? बिकॉज 1 पे ये फंक्शन माइट बी ये डिसकंटिन्यूअस हो. इसकी कंडीशन इसलिए हम 1 पे लगा रहे हैं. अगर यहाँ पे कोई और नंबर होता 2, 3, 5 तो उस नंबर पे हम कंटिन्यूटी की कंडीशन लगाते हैं. तो लिमिट x अप्रोचेस टू 1, f ऑफ x ना लिखें आप, y ऑफ x लिख लें क्योंकि y ऑफ x आपका यहाँ पे सॉल्यूशन है. तो y ऑफ x it should be equal to what? y at 1. So this is the condition of continuity जो आपने कैलकुलस में पढ़ी होगी. I hope you remember it. अगर नहीं तो you can revise it by looking at the calculus book. So अब इस पे ये कंडीशन कंटिन्यूटी की कंडीशन लगानी है. ठीक है, अब देखिए यहाँ पे 1 पे ब्रेक है. ठीक है, यहाँ पे लिमिट की कंडीशन व्हेन x अप्रोचेस टू 1. क्योंकि 1 पे ब्रेक है यहाँ पे तो हमें या यहाँ पे लेफ्ट हैंड लिमिट और राइट हैंड लिमिट को सेपरेट करना पड़ेगा. ठीक है, यहाँ पे कंडीशन ऑफ कॉन्टिन्यूटी में आप इसको थोड़ा सा अगर एलाबोरेट करें तो ये कंडीशन क्या होनी चाहिए? लिमिट x अप्रोचेस टू माइनस x फ्रॉम द लेफ्ट हैंड साइड. इट शुड बी लिमिट x अप्रोचेस टू 1 फ्रॉम द पॉजिटिव साइड एंड दिस शुड बी इक्वल टू वैल्यू ऑफ द फंक्शन. अगर थोड़ा सा इसको मजीद एलाबोरेट करें कंटिन्यूटी कंडीशन को तो it should be like this. Left hand limit at 1, right hand limit at 1 or value of the function at 1. These three things should be identical. So अब हम यहाँ पे आप ये दोनों लगा लें या ये दोनों लगा लें, it doesn't matter. Continuity condition हमने यहाँ पे लगा के ये इसकी constant की वैल्यू फाइंड करनी है. Whenever x is हम कौन सा यूज कर रहे हैं? ये दोनों यूज करते हैं. ठीक है, when x is approaches to 1 from the positive side आपके पास ये फंक्शन होगा और जब when x is equal to 1 तो ये वाला फंक्शन यही होगा. फिर आप ये वाला और वो वाला यूज करें. You cannot write this, you cannot use this one because इससे आपके पास दोनों केसेस में यही फंक्शन आ रहा है. So you use y at 1 and the left hand limit, this one. ये दो कंडीशंस आप यूज कर लें. लेफ्ट हैंड लिमिट व्हेन x is approaches to 1 from the left hand side फंक्शन कौन सा होगा? ये वाला. और जब x is equal to 1 होगा y at 1 तो फंक्शन ये वाला होगा. ये दोनों आपस में सेम होंगे तो हम इनको यूज कर लेते हैं. व्हेन x approaches to 1 नेगेटिव फंक्शन आपके पास x स्क्वायर ओवर 2 into 1 plus x स्क्वायर होगा. दिस शुड बी इक्वल टू व्हेन x is y when x is equal to 1 तो आपके पास ये क्या आ जाएगा? 1 plus 1 का स्क्वायर माइनस 1 का स्क्वायर डिवाइड बाय 2 plus c2. यहाँ पे लिमिट x approaches to 1 होगा तो आपके पास 1 divided by 2 into 1 plus 1 is equal to 1 by 2 minus 1 by 2 plus c2. ये 1 by 4 है, ये 2 और 2 कैंसिल हो गया तो आपके पास यहाँ पे 1 by 2, 1 by 2, ये 1 by 2 इधर आके प्लस हो गया तो C2 की वैल्यू आपके पास 1 होगी, ठीक है। C2 की वैल्यू आपके पास 1 होगी। अगर C2 की वैल्यू 1 है तो यहाँ पे इस सोल्यूशन में आपके पास फाइनली आपके पास सोल्यूशन क्या आ जाएगा, सोल्यूशन में यहाँ पे 1 आ जाएगा। So this is your required solution, which is uh, differentiable up to order 1 on this interval from 0 to 1 and from x greater than equal to 1. Now you can have a look at this solution. If you have any question, you can ask me. Now we are going to discuss exact equations. Exact ODEs. But before discussing these things, these equations, exact equations, we need to discuss differentials. Differentials for, you can say, two independent variables. In calculus, you have discussed differential for, you can say, single variable functions. Now, we are going to discuss differentials for the two independent variables. For example, let z is a function of x and y. Okay, this is a function of two independent variables where x and y are independent variables, and z is differential. Z is dependent variable here. Now, the differential of this function, the differential of z is defined by, कैसे define करेंगे इसको, dz is equal to partial f partial x dx plus partial f or partial y dy. Now, what is this partial f or partial x? It's a partial derivatives. I hope you know what is a partial derivative. आप लोगों ने partial differentiation थोड़ी बहुत पढ़ी हुई है या नहीं? If we have any function f of x y is equal to x squared plus x into y plus y squared, so इसका partial f और partial x क्या होगा? Partial f और partial x. इसमें x को हम वेरिएबल कंसीडर करेंगे और y को एज अ कांस्टेंट ट्रीट करेंगे, ठीक है। तो पार्शियल एफ और पार्शियल एक्स क्या होगा, एक्स स्क्वायर का डेरिवेटिव 2x प्लस y यहाँ पे कांस्टेंट होगा, y एज इट, x का डेरिवेटिव 1 प्लस y अगर कांस्टेंट है तो y स्क्वायर कांस्टेंट है तो कांस्टेंट का डेरिवेटिव 0 होगा, ठीक है। सो दिस इज द पार्शियल एफ और पार्शियल एक्स फॉर दिस एफ ऑफ एक्स वाई, एंड पार्शियल एफ और पार्शियल वाई, इसमें डेरिवेटिव विद रिस्पेक्ट टू y होगा और x को एज अ कांस्टेंट ट्रीट करेंगे, ठीक है। तो x यहाँ पे x स्क्वायर कांस्टेंट होगा, इसका डेरिवेटिव 0 प्लस x यहाँ पे कांस्टेंट x एज इट, y का डेरिवेटिव 1 प्लस y स्क्वायर का डेरिवेटिव 2y। तो पार्शियल डिफरेंशिएशन में आप जिस वेरिएबल के विद रिस्पेक्ट से डेरिवेटिव फाइंड कर रहे हैं वही वेरिएबल जो है उसको हम वेरिएबल कंसीडर करेंगे। इसके अलावा जो दूसरा वेरिएबल होगा, मतलब यहाँ पे पार्शियल एफ और पार्शियल एक्स फाइंड कर रहे हैं तो y को एज अ कांस्टेंट ट्रीट करेंगे हम, सिर्फ x उसमें वेरिएबल होगा और उसी के रिस्पेक्ट से डेरिवेटिव फाइंड करेंगे। सिमिलरली पार्शियल एफ और पार्शियल y कैलकुलेट करने में हम x को एज अ कांस्टेंट ट्रीट करेंगे, ठीक है। दिस इज हाउ वी टेक पार्शियल डेरिवेटिव्स, ठीक है। सो किसी भी अगर आपके पास फंक्शन है टू इंडिपेंडेंट वेरिएबल्स का, ठीक है, तो इसका जो डेरिवेटिव होगा, सॉरी इसका जो डिफरेंशियल होगा dz It involves partial f over partial x dx and then partial f over partial y dy. Okay, this is how we define differentials. Is there a question in the chat window? Um, okay. Now let's discuss a couple of examples for this thing. Okay. अब देखिए अगर हमारे पास वन पैरामीटर फैमिली सॉल्यूशन है, ठीक है, फॉर एग्जांपल if we have one parameter family of solution, that is, इसको हम कैसे लिख सकते हैं, f of x y is equal to c. ठीक है, किसी भी वन पैरामीटर फैमिली ऑफ सॉल्यूशन को हम इस तरह भी लिख सकते हैं, या हमने जो प्रीवियसली लिखा था उसमें लिखा था कि x y c equal to 0, इस तरह भी लिख सकते हैं. This is also a one parameter family of solutions and we can also write that one parameter family of solution in this way. ठीक है, अब अगर आप इसका डिफरेंशियल लें तो df क्या होगा, df should be partial f over partial x dx plus partial f over partial y dy equal to कांस्टेंट है तो कांस्टेंट का डेरिवेटिव 0 हो गया. तो फॉर एग्जांपल ये वन पैरामीटर फैमिली ऑफ सॉल्यूशन, अगर हम इसको अस्यूम करते हैं कि इसमें f of x y आपके पास x स्क्वायर मे बी x स्क्वायर माइनस 5xy प्लस y क्यूब इक्वल टू c है. ठीक है, अगर ये आपके पास है, इसका डिफरेंशियल क्या होगा, इसका डिफरेंशियल पार्शियल f और पार्शियल x, तो ये क्या आ जाएगा 2x माइनस 5y, क्योंकि x का डेरिवेटिव 1 हो जाएगा और y क्यूब का डेरिवेटिव 0 और यहाँ पे साथ में dx, ये हमने पार्शियल f और पार्शियल x डिफाइन किया, प्लस अब पार्शियल f और पार्शियल y क्या होगा, यहाँ पे x स्क्वायर का डेरिवेटिव 0 माइनस 5x क्योंकि y का 1 डेरिवेटिव और माइनस प्लस यहाँ पे 3y स्क्वायर, ये आपका y क्यूब का डेरिवेटिव रिस्पेक्ट टू y आ जाएगा, साथ में dy इक्वल टू 0. ठीक है, क्योंकि कांस्टेंट है तो कांस्टेंट 0 है. अब आपके पास कोई भी वन पैरामीटर फैमिली ऑफ सॉल्यूशन है तो वहां से हम ये एक एक्सप्रेशन डिफाइन कर सकते हैं, और ये एक्सप्रेशन क्या है, इट इज बेसिकली द फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन. फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन ये कैसे है, यहां से वी कैन डिराइव अ फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन फ्रॉम दिस इक्वेशन. अगर आप यहां से देखें तो ये क्या आ जाएगा, इसको आप दूसरी साइड पे लेके जाएं तो क्या आएगा, 5x माइनस 3y स्क्वायर dy इक्वल टू 2x माइनस 5y टाइम्स dx. ठीक है, यहां से आप इसको उधर डिवाइड कर दें तो आपके पास dy बाय dx इज इक्वल टू 2x माइनस 5y ओवर 5x माइनस 3y स्क्वायर. क्या आ गया. Now here, what is this thing? It is f of xy, and on the left hand side, we have dy by dx. So this is first order differential equation. Now, if we have a one parameter family of solutions, and if we take its differential, it gives us a first order differential equation. Okay. Similarly, आप ये कह सकते हैं कि अगर फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन है तो अगर उसका वन पैरामीटर फैमिली ऑफ सॉल्यूशन फाइंड करें तो वो इस टाइप का भी हो सकता है. Okay? For the time, for now, we stop till here, and we shall discuss again the exact differential equations in the next lecture. Now, if you have any question regarding today's lecture, you can ask me.
Sorry, do we